Hello, my name is Lisa. In this video, we're going to talk about linear inequalities in one variable. As a definition, inequalities compare two quantities. Write the inequality in words. So just to go over some of the symbols that we use, 3 is not equal to 5. The equal sign with a line through it means not equal to. 7 is less than 8, or 7 is less than or equal to 8. When we put the little line here under the inequality symbol, that gives us equality as well as inequality. 25 is greater than 5, and 25 is greater than or equal to 5 because, again, we have that little line there. Now, a lot of students have gotten confused in school about the big fish eating the little fish and all sorts of stuff. This is the way that I think about it. When you look at an inequality sign, I think that it has this little tiny point. The little end always goes with the little number. And this side is the big side, and the big side always goes with the big number. Doesn't matter which way it's pointing, the little number always goes at that little point, and the big number always goes on the big open side. And that's how I remember which is the big and which is the little. So when we're asked to change the direction of an inequality sign without changing the meaning of the statement, what we're going to do is we're going to turn it around. So this statement starts off saying 7 is less than 8, but I can flip that inequality sign over as long as I still put the littler number on the little point. So 7 has to go on the little side and 8 has to go on the big side. The inequality 7 is less than 8 is the same as the inequality 8 is greater than 7. 25 is greater than or equal to 5 is the same as saying 5 is less than or equal to 25. So when we look, the littler number is still at the little point of the inequality sign. Example 3 says x is greater than 3. That's the same as saying 3 is less than x. So when you change the direction of the inequality sign, you're also changing the side that the littler number is on. We're going to use interval notation to represent our solution sets. So when we're using our interval notation, we will use parentheses and brackets. So we'll use parentheses when the endpoint is not included in the solution set. For example, when we have a less than or a greater than as our inequality symbol. We use a bracket, so these are little square symbols, when the endpoint is included in the solution set. So in otherwise, when we have the inequality symbols less than or equal to and greater than or equal to. We use a parenthesis, again, these symbols, with every symbol representing infinity. So the two symbols that we have here, negative infinity, positive infinity, if one of those is the endpoint of your inequality, we will always use parentheses. And number 4 in this list says we use the interval that goes parentheses, negative infinity, comma, infinity, parentheses, to represent the set of all real numbers. Okay, all real numbers are all of the numbers that go from negative infinity to positive infinity. Everything in between is a real number. So we're going to talk about how to graph the solution set of an inequality. When we solve our inequalities, very similar to solving our equations, we're going to get the variable on one side by itself and numbers on the other side. So the first thing that we're going to do when we graph an inequality is draw a number line. So let's look at example number 1. We're going to start off by drawing our number line. We put arrows at our number line. Our number line, you can start with 0 in the middle, doesn't have to be 0. And positive numbers go to the right, so let's do 5, 10, 15. And as we keep proceeding to the right, we use the symbol infinity to indicate that that keeps going in that direction. And when we go to the left of 0, we get negative numbers, -5, -10, -15. And as we keep going left, we head out towards negative infinity. Now, negative infinity and infinity are not exact numbers like 5 or -10. They're kind of an idea that says keep going. So we can never be equal to negative infinity or positive infinity. So that was step 1. We've drawn our number line. Step 2 says we want to shade to the right or to the left of the number. So in order to do this, we have to read our inequality. We want all of the numbers x that are bigger than or greater than 5. So 5 is my little number. 5 is going to be on the left-hand side of my shading. X is going to go to the right or the bigger side. So the bigger numbers, if x is bigger, it's always going to go to the right. So we want to start at 5 and shade our number line going in the right direction. And then in step 3, it says write a parentheses or a bracket at the number. So at our number, we have the inequality sign just greater than, so that tells me that I need to use a parenthesis. I would only use a bracket if it said greater than or equal to. So I'm going to use a parenthesis on my number line. And then to write, this is my graph, and to write my solution in interval notation, I'm going to look at the graph, and I'm going to look at where my shading is. I have the left edge of my shading, and I have the right edge of my shading. When I write my intervals, I always want to go in the same order as my set appears on the number line. So at the left edge, I have a parenthesis with a 5. All the way out going to the right, we're going to infinity, and we always use a parenthesis with infinity. So this is our interval solution for the inequality x is greater than 5. And you can check, pick a number in this interval. So is 10 bigger than 5? Does that make it true? Yes, that makes my inequality true. 10 is greater than 5. I know I've shaded in the correct direction. Example number 2 says x is less than or equal to 2. So I'm going to start by drawing my number line from negative infinity to infinity. 0, 1, 2, 3. Positive numbers to the right. Negative numbers to the left. Now we need to determine which way are we going to shade, to the right or to the left of 2. So when I look at my inequality, this says x is less than or littler than 2. If x is less than, I want x to be on the left. So at 2, I'm going to start shading to the left. And then I look at my symbol. I have a less than or equal to symbol, which means I'm going to use a bracket. Less than or equal to says we're going to use a bracket. Now we put the bracket at 2 and it's going to the left, so we do it this way. And again, when I go to write my interval, I look at my shading. My shading goes from left to right. That's how I'm going to write my interval. On the left-hand side, I'm starting at negative infinity. And at negative infinity, we always use a parenthesis, comma. At the right-hand side, I've got the number 2 with a bracket. And that's how I write the interval that gives my answer. Now, I'm going to warn you, oftentimes in the online homework and in the textbook, they'll ask for the interval first and then the graph. I like to do the graph first because your interval, you're more likely to get that in the correct order if you do the graph first. And just as a reminder here at the bottom of the page in your workbook, you've got this note that the numbers should always be written in order. Smaller numbers on the left, larger numbers on the right. So always in the same order as the number line. And this includes negative infinity and positive infinity. Negative infinity is always on the left and positive infinity is always on the right. Now we're going to talk about how to solve a linear inequality. We're going to use primarily the same steps that we did with solving linear equations. Step 1 says simplify each side of the inequality. Clear parentheses, clear fractions, combine like terms. Step 2, use the addition property to get all the variable terms on one side of the inequality and numbers on the other side of the inequality. Now step 3, this is where we get a little bit different. Starts off the same. Use the multiplication property to get the variable by itself. The multiplication property of inequalities differs from the multiplication property of equality as follows. I like to put stars here, just as kind of a reminder. This is our special step. When you multiply or divide both sides of an inequality by a negative number, you must switch the direction of the inequality sign. Now I want you to think about, why do you do that? Why is that true? Let's think about when we draw numbers on our number line. From 0, we always count to the right in the positive direction. So when I look in the positive direction, I know that 2 is less than 3, right? The 2 is littler than 3. The little number is always on the left. Now think about when we count 0 to the left, we go -1, -2, -3. Notice my numbers have now switched their order. So if I were to think about multiplying my inequality, 2 is less than 3, multiply each side by -1, what do I get? I get -2 and 3. Well, what order do -2 and -3 go in? -3 is now less than -2. We have to switch the direction of the inequality sign. -1 times 2 is -2. -3 times 1 is -3. And which one is the littler one? Which one is left of the other one? The inequality sign always points to the little one, the one on the left on the number line. So notice when we multiply by a negative number, it switches the order that we have. That works with both multiplication and division. So that's an important step to remember. The other thing that's going to be different is when we give our solution, we're going to give the solution as a graph and in interval notation. In number 5, we can check our answers. So let's do a couple of examples. We're going to solve the linear inequalities and give the answer as a graph and as an interval. So just like with the equations, if we draw a vertical line here to separate the left-hand side from the right-hand side, we do that right at the inequality symbol. Here we have x plus 7 is less than 10. I want to get x by itself. My addition property says plus and minus go together, so I'm going to subtract 7 from both sides, and I get x is less than 3. I did not multiply or divide, so my inequality sign stays the same. I've got x is less than 3. Draw your graph. And I like to put a couple numbers on each side of 3 and just kind of think of which side am I going to shade with. I have x is less than 3, so x has to be on the left of 3. So I'm going to shade from 3 on down to the left. And I have the less than inequality sign, so it tells me I'm going to use a parenthesis at my number 3. My inequality at the left-hand side of my shading, I have negative infinity, and we always use a parenthesis at negative infinity. And on the right-hand side, our interval stops at 3, and 3 has a parenthesis. Now, if you have a hard time with which side to shade on, think about picking numbers on either side of 3. Pick one. Is 1 less than 3 or is 5 less than 3? This one's not true, so we shouldn't have shading. This one is true, and that is where our shading is, on that side of 3. And that's a nice way to check your answer to make sure that you've got your interval in the correct direction. Example number 2 says we have negative 3x is greater than or equal to 15. This is negative 3 times x, so to get rid of the negative 3, I need to divide by negative 3. Now I am dividing by a negative number, so what do I need to remember to do? Change the direction of the inequality sign. Greater than or equal to becomes less than or equal to. And I have still on this side, I'm going to follow the rest of the inequality down. X is less than or equal to negative 5. I'm going to draw my number line. When I have bigger numbers like 5 or 8, I like to count on my number line, mark my little lines by units of 4 or 5, whatever happens to work for that particular problem. But again, positive numbers go to the right, negative numbers go to the left. Now this time I have x on the little side of the inequality. Little side, it's going to the left, so I'm going to start at negative 5 and shade to the left. I have less than or equal to, so I'm going to use for my equal to ones, I'm going to use that square bracket at my number. And my interval, the left edge starts at negative infinity. We always use a parenthesis with negative infinity. It goes out to negative 5 with a bracket. And for our third example, this one's a little bit more complicated. We need to simplify each side first. So think about where your sides are. Need to distribute to get rid of my parentheses. 2x minus 10 plus 3 is greater than or equal to 9 minus 2x. Combine your like terms on the left, and we have 2x. Oh, that moved out of place. 2x minus 7 is greater than or equal to 9 minus 2x. If I want to get all my x's together on the same side, I'm going to add 2x. Whatever I do on the right, I have to do the same thing on the left. 2x plus 2x is 4x minus 7 is greater than or equal to 9. Now I need to get all my numbers on the same side, opposite from my x's. So 4x minus 7, I'm going to add 7 to both sides. And I get 4x is greater than or equal to 16. 4 times x, we need to divide both sides by 4. And I have to think I'm dividing, but my number is not negative. So I have x. Keep the inequality sign the same, x is greater than or equal to 4. When I draw my number line, and here I'm going to mark off in units of 2, 2, 4, 6. I want x to be on which side of my inequality? X is on the big side. The big numbers always go to the right. So there's my shading. Again, I have the equal to in my inequality, so I'm going to use that square bracket for equal to. And when I write my interval, I have a square bracket at 4. I go to infinity, and at infinity, I always use a parenthesis. So there's my interval answer. And that concludes section 11.2. This is Lisa telling you all to have a great day.